Hello, my name is Noboru Harada, a presenting author of the paper titled ToyADMOS2, another dataset of miniature machine operating sounds for anomalous sound detection under domain shift conditions. ToyADMOS2 is a new large-scale dataset for anomaly detection in machine operating sound. It is designed for evaluating anomaly detection systems under domain shift conditions. The dataset is freely available at the following link. A subset of the dataset is used in the DCASE 2021 Challenge Task 2. In ToyADMOS2, we collected operating sound of miniature machines under normal and anomaly conditions by deliberately damaging them. There were 5 machine configurations A, B, C, D, and E for toy car and toy train data subsets. The depth of damages was carefully controlled to represent 3 different damage levels in the anomaly samples. There are several variations that make it possible to design domain shift conditions. There are 5 model types in each toy type. 5 different speed levels are recorded. There are 4 types of anomaly conditions, and each anomaly condition has 3 damage levels. In addition, there are 4 types of background noise samples to be mixed with normal and anomaly samples. There are 4 types of anomaly conditions. For toy car subdataset, bent shaft, deformed gears, melted gears, and damaged wheels are the 4 types of anomaly conditions. Those anomaly conditions were generated by deliberately damaging parts such as gears and shafts. This slide shows the 3 different levels of damages on melted gears. The gear with the damage level high has the most significant damage as marked in the red circle. These are the damaged wheels. Actual recordings are conducted with toy cars called Mini 4WD. 5 microphones are used. Channels 1, 2, and 3 are omnidirectional dynamic microphones, and channels 4 and 5 are condenser mics. There are 4 types of anomaly conditions for toy trains as well. For obstructing stone, several portions of railway track have been damaged. The second one is disjoint. The spacing of the railway joint was changed as damage levels. Here are the broken shaft marked with blue circles and the flat tire marked with a red circle. The microphone arrangement for the toy train is shown in the left side figure. Channels 1 to 4 are omnidirectional dynamic mic, and channels 5 to 8 are condenser mics. The operating speed of the train can be controlled with a speed control device. On the ToyADMOS2 dataset GitHub link, there are several Python scripts and recipe files to generate example test datasets. You can download the data files and run the scripts for generating the test datasets. With the example recipe, the script generates 1 source domain with 4 target domain conditions. This domain shift condition contains model shift, operating speed shift, mic and noise shift, and combination of all of them. You can make your own recipe file by simply editing the template Excel file and running mixer.py to generate a test dataset. This slide shows the anomaly scores of the dataset under clean conditions, calculated by using the DCASE 2020 baseline autoencoder. It is shown that when the damage level is higher, the average anomaly score in the class is also higher. It is also shown that detecting anomalies on toy cars is slightly easier than that of on toy trains because the anomaly score of the normal sample is separated from that of anomaly samples in the toy car. This is the AUC and PAUC performances of the top 5 winning systems and the baseline autoencoder in the DCASE 2021 Challenge Task 2. Performance of the systems under domain shift conditions are relatively good for toy car, but for toy train, the baseline autoencoder performs better than others for target domain results. In this paper, we propose ToyADMOS2, a new dataset for anomaly sound detection. It consists of 2 sub-datasets, toy car and toy train, for machine condition inspection. Domain shifts are represented by introducing several differences in operating conditions, such as different machine models and parts configurations, operating speeds, microphone arrangements, and background noise types. The datasets can be used to assess anomaly detection systems. It is desired to develop anomaly detection systems working well even under domain shift conditions.